Okay, let's start. I believe the ones that are here, they have need for such. So let's talk about, please class, can I listen to you again? Define that word wave. That's a good one. But I'm happy that some of you were busy reading from their notes. Some are reading directly from the notes. Even when you know that you are going to recite that definition for me, you still, I saw some people, their faces on their notes throughout without raising up. That's okay. So can you repeat that, because I want to talk about it. Can you repeat it again? Thank you. So what we're saying is that it's a disturbance that transfer energy from one point to another. For example, let me take this. I want to go this way so that we understand better. I have a full basin here and filled up with water, a tank, so filled with water. And I have a stone. If I drop the stone at the center, you discover that ripples will begin to move. Just look up here so that you understand it. These are all ripples. As they are moving, anyone that reach the edge of this tank will strike and begin to return back. Can you watch this? The one that is moving from the point of the stone is called incident waves. It's called what? Again. Because it is the one produced. It is the one produced. And this is the only one you can see. You can't see breeze when it is moving. There is no way you can see my voice, this sound coming from me when it is moving. They are all waves. We have the three areas. The three major areas we study. One is the water waves. Another is the light waves. Another is the sound waves. You can see all of that. You can see light of the torch traveling. You can see the light here reflecting. This light strike and reflect, yes. But you easily notice and read that of the water. So the water waves is more visible for you to understand all aspects of waves. So when you look at it now, these ones that are going from the source is called incident waves. They are called what? The ones that strike and begin to return back, they are called what? Reflected waves. Say it again. Now we want to deal with the incident waves only now. Let's take it one by one. I may not go the way it is in your note elsewhere. No, I want you to understand the basic. So I'm taking number one, water waves. So write down, among all waves, I'm taking up the water. Water waves. Water waves. If you can understand what is involved here, every other one will be easy for you. Because this is the only one you can see physically and visibly. Water waves. Now, we said that water waves is produced using what is called ripple tank. Using what? Using a ripple tank. Ripple tank. A ripple tank is just a very simple machine that when you pour water into it and cue in, the vibrator will begin to beat the surface of the water and waves will be traveling. If the vibrator is bar, it will produce bar waves. If it's circular, it will produce circular waves. As this vibrator is producing these waves, you use what is called stroboscope to view the movement of that waves. A stroboscope is also a very simple machine flying like this fan. You know, as you see this fan rotating, if this fan is on a very high speed, you will not know how many blades that are involved. Are you with me? If it's, okay, like as you look at it now, can you see the number of blades? Somehow you can see. But when the speed is more, you just look at it as what? One. So stroboscope is like a fan. When you start it, it will rotate. And the motion of it will now cause that of the water to appear stationary to you, though it is moving. And with that now, you'll be able to read what we call the lines of the contour of the lines. And this contour of the lines are the anodes, the cathodes, the down depressions, and the upward depression, upward verticals. You'll be able to read those things and record them. When you record those things, you record them like these are amplitudes, which are vertical displacement, downward displacement. So when you look at the water waves, we said it is the machine used, it's a device used to produce moving water waves. To produce what? Moving water waves. And we can easily read its movement using what? Using what? Stroboscope. Just as pronounced, write it that same way. Stroboscope. Stroboscope. I had just studied here. And I said it rotates like a what? The fan blade. Like the fan blade. On our speed. And because of its rotation, you will not be able to see whether it is one blade or two or three again. But it will appear transparent so that you see the movement of those waves in what we call the relative velocity. In what we call the what? The relative velocity. And because of its movement, I want you to look up here. This body now we're studying. This is the vertical. Please look up. From the center here, I have a vertical. I have a horizontal. Just look at the board. This is vertical. This is horizontal. And this is the point where the wave started. When the wave is moving towards X plus, the movement will be like this. Please look up here. Look at how the movement will appear. This is upward, this is downward, upward, downward, because we call it sinusoidal. But when it is seen to the X negative, it will appear this way. Look at from here now is down, but from here is up for the positive. For the positive. This is the plus Y, and here is minus Y graphically. So this is the nature of the waves. I want to teach you this based on one side alone. But I will combine the two sides. Looking at it now, I have that of the positive and negative. What? That of the what? If I combine two of them, I will obtain an equation for the motion of the wave, saying that anytime the Y positive is mentioned, it is equivalent to amplitude sine into WT plus or minus alpha. This is what we have. Hence, you see a wave moving. This is the wave equation. I want us to begin with this. The way you know these things in your textbook, don't bother about it. You get to the end and you understand them well. Anytime you see a wave moving, It is classified by this equation. This is the wave. And this wave is saying that the positive y, this positive y, is equivalent to the amplitude sine omega t plus or minus phase difference. Let me repeat. Please say this after me. The positive y is equivalent to amplitude sine, again, into omega t. That omega is angular frequency. The omega is what? Or angular velocity. Or what? Plus or minus phase difference. Phase, P-H. P-H-A-S-E. Phase difference. Phase difference. Now, I want to bring it too low so that I'll be able to catch everything till the end of the waves. So what we're saying is that hence you see a wave moving, whether it is water, sound, wind, light. That is exactly the equation. And based on this equation, we now pick this same equation that A is equivalent to what? What is the value of A? Amplitude. Again. Again. What is the name given to W? Angular frequency or angular velocity. Say it again. What is this alpha? Phase what? Phase difference. Phase difference. That now let's give the meanings of this. In the first place, A is just the same A. But mathematically, this one is given as 2 pi f. Anywhere we see it, whether in mechanical or under waves, it is 2 pi f. Everywhere, 2 pi f. Hence, we see W, 2 pi f. 2 pi f. So this is the value of 2 pi f. For a body to be in motion, for a wave to travel from one point to another, its angular frequency is 2 pi f. And the unit is radian per second. The unit is what? The unit is what? They follow. Because they talk with your mind and strength. There's no T in the formula. Okay, no. There's not. T will not come in because that T has no function in that equation. It will not come in for interpretation. Where T will function is still coming. So now, anytime we talk about W, it is 2 pi f. And the unit of the W is radian per second. But anytime we talk about phase difference, it is kx. Or the value of this k is 2 pi all over lambda. Then this k now multiplied by this will now give us the whole of 2 pi x over lambda. 2 pi x over lambda. 2 pi x over lambda. So let us learn these things gradually. Just hear notes. Most of us in our various schools, we just presented notes, long notes. You start sleeping. So it is better for you to understand the keys, so that when you see question, you solve happily. Now, so what is the value of alpha? What's the value of this alpha? Kx, or what again? Thank you. That's the value. Then let's still go back to the interpretation. Anytime this phase difference, I hope you are following. Hence, you hear me talking, please, let me have your attention. Anytime you see alpha, this alpha recorded in degree, recorded in what? It means that the value of this pi is equivalent to 180 degrees. Any question, any equation, where you see that the alpha has degree on top of it, it means when you come back to the value of this alpha as 2 pi x over lambda, replace this pi with what? With 180 degrees. You discover that you are moving. That is the value. Hence, you see that alpha is in degree. Replace the pi with what? 180 degrees. Those ones at the back, are you with us at all? Thank you. But anytime I see the same alpha, this same alpha in radian, it means that the value of pi is 22 over 7 or 3.142. That is exactly. So look at them. Hence you see a question. Check the first difference. Check the unit. If the unit is degree, it means that the value of pi is what? 180 degrees. If it's in radian, the value will be what? 22 over, or equivalent to what? 3.142. 3.142. 3.142. Okay. Now, it's only in rare cases like in year 1, they will ask you to convert this to a log. Converting it to a log in year 1 means the log of it is 0.4972. That is approximately 71, but approximately 72. It's only in your year 1 application, fees application, that will tell you to change it to a value, to a log value, which is 0.4971, but approximately 72. That is just to give you this, just like notice, so that when you see it anywhere, it will not be like, hey, I've never seen such before in my life. So this is exactly. Then, based on this, let's go back to that diagram. We'll pick the extension of that diagram, develop the equation, make use of it, solve questions. In our next class, we finalize, and then we pick up another base area. By the time we round up the whole of the waves, you will understand exactly that those things in your textbooks, there are things that are not difficult. So let's come back to this. So let us reply ourselves now. What's the name given to A? What about the name given to W? Thank you. What's the mathematical value? What is the unit? What about this? Phase difference, or mathematically you call it what? Alpha. Alpha. Then what's the mathematical value? Kx, or what? Thank you. Now, what is the value of the same phase difference when it is measured in degree? Thank you. What about when it is measured in radian? Fine. Let me now take you back to this diagram. So for the waves, common waves now, which is said to move this way, all the waves moves like this, the same way. All waves, this is the movement. It is all sinusoidal. But you don't see them. You can only see water waves. That's why we are using water wave for our demonstration. And we say that these water waves can be easily produced directly by you using a what? Using a what? A ripple tank. And you can now view it using what? Stroboscope. Thank you. Thank you. So if we now decide to produce If we have a ripple tank here and we say, let's produce the waves, and we on it, it is beating. We'll see the waves, and we on the stroboscope and read the intervals. At the end, we discover what is on the board. Now, this on the board, I'm going to pick one side of it and work with it. I am picking plus y and plus x only. All other ones, they are the same. But I want to pick the area that will help you understand it better. So let me pick plus y and minus y. So I have here, I have a line here, another line. So this is plus y, this is plus x. Now, this is the wave. This is sinusoidal wave. This wave now, the peak of this wave is called crest. It's called what? It's called what? And the bottom of this is called what? Thank you. So if I have here crest, and I have here crest, I have here again crest. How many of them? Huh? This is a place I want you to, I need your interests. I have 3 of them. But if I want to count them, how many? If I want to check them from the point, how many will I see? Thank you very much, Obigidia. I am standing at crest, and I have, this is the place I'm standing now. I have another in front, so I can only see 2. These 2 now, in my mind, the distance between where I'm standing to the last one I can see, all together, is meant to be wavelength. It's meant to be what? I am coming with descriptions. That's why I say, let's go primary way. In a very, very, very primary form. I got touching hand and then we can move on. Sorry. I'm the phone too much. Just leave it like that so that I can open and read. The SI unit of W is radian per hertz. Oye drinka need the kemetu yaka. Okay, radian hertz. Do you know that that frequency is per second? Have you ever heard of before? Frequency is hertz or per second. You can't use hertz together with radian. No. No. It is per second that must go with radian per second. Radian per second. It is not what you see that make up that unit, please. Stop confusing yourself. Which is actually, please briefly explain. This is exactly where we're standing. Yes? Trough. Yes, now. Anything, either crest or trough, they operate on the same level. This one is up, this one is down. So with this now, I want you to look up again. Because these are 3 key areas that in your JAM and SSCE sometimes you get confused. So look at this. Let me tell you why these 3. I am standing here, you say 1, 2 as wavelength. Let me divide. This one now gave me one phase. This is a phase 1. A phase is half of 180. A semicircle is 1/8 of here. And a complete circle is what? So this is a semicircle of here, which is what? 180. So here, this is 1. This is 2, 3. And this one ended at 4. So every 4 phase, whether they are together or with the up, down, down, or up and down, we give you wavelengths. Let me go by this again. Look up again. Please, let your attention be here. I rule from this place as wavelength. Look up here. This is another wavelength. From this line to this line is another wavelength. Because I have 1, 2 up, 1, 2 down, which is the same 4. So when I have together 2 up, 2 down is a wavelength. 4 up, wavelength. 4 down, wavelength. Accept it in your mind so that you work with it. So with this now, we come up with the value of this y. That the value of the y is the same as a sine into wt plus or minus phase difference. And then we'll come up. That this y also will be a sine into w is giving us 2 pi f, then plus this t, plus and minus. Alpha is giving us 2 pi x over lambda. This is the same equation. So I have here equation 1, equation 2, then equation 3. This a sine also is here. I have frequency. And when you go back, you discover that frequency, that velocity is equivalent to f lambda. Have you heard of this before? So if I make the frequency the subject, what will appear here? Again. So I will replace this f with v over lambda. So this will be into 2 pi v over lambda t. V over lambda t plus or minus 2 pi x over lambda. So I still have another equation here. So look at it. The third equation. After this third equation, I'm going to now group it. So in grouping, I picked just this part, positive alone. But I'm using both plus and minus in my equation to tell you that the positive will go with positive, negative will go with negative. So with this, I can come back and group by saying that the same y is equivalent to a sine into, so instead of placing into here, I have common factors. Can you remind me the common factors here? 2 pi, thank you, over lambda. That's the common. Into, what is remaining here? Vt, plus or minus. What is remaining? X. So this is equation what now? Equation 4. This is equation 4. Then, within this now, I can also come back here. Instead of using equation 2, I will come back and see that also the period of oscillation is 1 over f. Have you seen this before? Have you? Which means that the frequency is equivalent to 1 over what? With this now, that's why when you go to JAM, you get confused when you don't know the principles there. You discover that I can also replace this by saying that y is equivalent to amplitude sine into, instead of writing 2 pi ft, I will write 2 pi t over big T. Yeah, over big T. Then plus or minus 2 pi x over lambda. So this will give me what? Equation, this is IV and this is V. Equation 5. So please, I'll pause for a while. Copy these equations. Copy the equations. The last one. Just copy the equations first. Copy as they are. Let me. So after writing these things, we now see the need to define this item, because when we just do definition, you wouldn't know exactly what you are defining. As somebody asked me to define amplitude. It is now that you know what is amplitude, and you know the source of the amplitude. Because you can't talk about amplitude when you don't know where you locate it. And where do we see the amplitude from the diagram? That's the question. The amplitude from the diagram is from the point C down. So look at the amplitude. Please represent this. This is a point called amplitude from 0. Here is 0. From this point down to 0 is the amplitude. 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 So we have amplitude up, we have amplitude down. Positive and negative. So this is the amplitude. This is minus A. And here is plus A. That's the amplitude. So right quickly, and let us now go into the use of these parameters. Sometimes for me to achieve maximum value or targets, I normally begin with the mathematicals and keep those definitions by the side. When we understand the meaning of the equation, the mathematical values and how they are used, I can now go into those definitions. So please, I want you to understand every bit of the parameter on that board. Anyone you don't know, that's what you are going to ask me now. You don't know the meaning and its function. That's exactly what you ask me now. Because I'm going to talk about them again. I'll call all of them one by one and you tell me their meanings. Or you pronounce them completely. Yes? Of x, distance. Okay. Are we through? Now, I want to pronounce, sorry, I want to mention the alphabets involved. I have, from the equation, I'm beginning with equation 1. I have y. What is that y? What's the y? What is y? Positive y. And then now, what is y? Thank you very much. Displacement. Y is a displacement. Can you pronounce it? Y is a displacement. Can you pronounce it? Again. Anywhere you see y is a displacement. But A, capital A is amplitude. Is what? Capital A is what? And amplitude is called maximum displacement. That means it's superior than that of y. So can you give me the meaning of amplitude? Again. Again. That is the one. That's the A. Capital A is a maximum displacement anywhere it is. Maximum displacement. So from the same, from equation 2, I have F. What is that F? Again. Frequency. F is the frequency. And frequency means number of cycles per second. Can you repeat it? Number of cycles per second. Can you say it again? That is frequency. 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 That's the frequency. Then I have another one on the same line, X. X means distance traveled by the waves. Can you say it again? Again. Sorry, your horizontal distance traveled by the waves. That's the x. X is a horizontal distance traveled by the waves, by the entire waves. That's the distance. But I have another one called lambda, and that is under 2 pi x. You got for lambda. Lambda. What's another name for lambda? Again, wavelength. Can you say it now? Wavelength. That's lambda. So lambda is a wavelength. Wavelength. So this wavelength, which is the lambda, can you see exactly where I represented the lambda? So what make up the lambda? How many? Between two successive crests or trough. Or what else make the lambda? Four phase. Four phase. Upwards or downwards. Or two phase up, two phase down. And that lambda is showing how many waves. Lambda is showing how many waves. Hell. Look at that lambda. How many waves is a lambda? Thank you very much. Half cycle make up one wave. Make up what? So a complete wave is equal to what? One lambda. Equal to what? Equal to what? Now look at that board. Look at the board. How many wavelengths are there on that board? How many wavelengths are there on the board? Look at it very well and count. Up you. That's the correct thing. So I have two complete waves and half on that board. It is better you understand these things. Let me take this too. Let me ask this question here. I have a line here, but this is, look at the board. Despite that some are small, some are big. Look at this one on the board. How many waves? How many wavelengths are there? 4 and let's check. This is what? This what? This what? This what? 4.5. That's for you. That's correct. So I have wavelength into 4.5. So if you can understand this now, you discover that that's exactly what you're supposed to know. So wavelength represent the number of waves in the system. It shows the wave pattern in a system. But the X is a total distance covered by the number of wavelengths. And that's exactly where we form the last equations under this. So looking at this now, we'll say that from here now, that we have 4.5 or 4.5 wavelengths to cover a distance D. And what's the distance D? From here down to this place. So this is distance D. So distance D is equivalent to 4.5 lambdas. That is exactly. If you can understand these things well, then it will no longer be a problem in solving the question. Now, what is V? When we see V, what is V? velocity. Now, where we have problem is just the mathematical issue. Many people can recite every other area, what make up the other types of waves, forms of waves, this, the meaning of each. But coming to the questions, that's why we have problem every year. Then I have a question here. We can start without question. I want you to understand exactly the mathematical application of the waves. Hence, you are through with the mathematical application of the waves. No problem. Okay. Now, this one has only x until without pi. So let's begin with the ones with pi. Can I clean the board? Now, let us use, I want us to use the formulas before we move ahead with definitions. So let's talk about motion, wave motion. Let's talk about wave motion. Wave motion. That is why we use these equations. Under the wave motion, we have a type of motion called, a type of wave called progressive wave. Called what? Called Guinea? Progressive. By progressive means the wave is moving completely. But when it is now stationary, it also has equation, but instant. So let's go by progressive. We have this, under the motion, we have only one, progressive motion or progressive wave. So this progressive now, we talk about number one. Under progressive, I want to give you question and then solve. After that, I'll keep repeating some questions and you solve. Now, write. Number one, write. I'm working on questions under the wave motions. Number one. Are we ready? The progressive wave equation. The progressive wave equation. The progressive wave equation is given by y equals, look at it on the board, y equals 3 sine into 40 pi t minus 4 pi x over 5, comma, where x in meter and t in seconds, full stop. Calculate number I, frequency, I, wavelength, I want to stop on this equation for this question here. Wave speed of waves, full stop. Now, not everyone can solve this immediately. I want to take it up first. We'll go one by one, gradually until we are okay. So look at that question. Can I clean this board? Yes. Want to make use of these equations derived. At the end of it, we'll move over to the definitions one by one. Of course, many of us can define many of these. Now, Help me read that question on the board. Okay, sorry, I have IV. Please add IV amplitude. Amplitude. Yes. I want you to help me read the question on the board. 1 to go. Please stop. I want to hear the house quietly. 1 to go. Now, some of us already solved the question, but there are ones that are yet to understand it. So stop writing and look at the board so that generally everybody will move with the same pace. Now, look at the board. From the board, they gave us an equation, and that equation carries minus. Now, anytime you see minus, it means that the wave is traveling to the right. But when you see plus, the wave is traveling to the left. You know, in the equation, you see plus or minus, okay? So when minus is there, it means the wave is traveling where? To the right. But when plus is in the equation, the wave is traveling where? To the left. And what is at the left? What is at the left? We know the left as for what? What is at the left? What sign is at the left? Minus x is at the left. So when the wave carries plus, it is moving towards that minus x. But when the wave carries minus, it moves towards where? Plus I gave you a diagram before. That diagram. And went right, left. Okay? And the right has plus what? Ended with plus x. That right with plus x can only accept a wave coming with minus sign equation. The left side has minus x. It can only accept a wave coming with what? Plus sign. Look at this one now. This question on the board, where is it traveling to? To the what? To the right. It's just exactly what we have on the board. Because from 0 now, this is right. If I continue this now, this is what? But this one is traveling to the right. So I will repeat that question. Look at the board. Y equals 3 sine into what? 40 pi t minus what? 4 pi x over 5. Now, when I see any equation, any question, sir, I will go to the equations from number 1 to the end and find out the one that will match the first 2 questions. What are the first 2 questions here? Again, frequency and wavelength. With this frequency and wavelength, I will go back to that equation, the line of the equations, and I will check among all of them which one will directly give me the 2 first informations here. Equation what? Equation 2. Equation 2. Can you read equation 2 for me? Now read it for me. So what will I remove here? What will I remove in this equation so that I will use it? Thank you. I'll remove plus. So this equation 2, I'll just come up and say, equation 2 is a sine into 2 pi ft minus 2 pi x over lambda. Over lambda. That is equation 2. I will close. Now look at the 2. This is my question. This is my equation. I'm going to use the equation on the question to give the answers. What's the first question? So I have number I, frequency. In my equation, is there anything like frequency? So what make up the frequency in my equation? 2 pi f what? Frequency there, I will pick everything there. 2 pi ft. That is the equation. But what of my question? This t now match with this up here. Anywhere t, they go with t, x goes with x. So I will now carry this equal to this. So I will say equal to 40 pi t. I will then cancel the ones that are common. Pi is common. What is remaining at the left? 2f is here. What's remaining at the right? Now the value of f will be 40 over what? Over 2. And that's what? I will write 20 Hz as my answer for frequency. So my frequency in this question is 20 Hz. I will come back again. The second question is what? Again, if you are talking, you will not know how I managed to get that. Wavelength. Is that in this my equation, is there any wavelength? Yes. And what make up the wavelength? Again, I'll bring out 2 pi x over lambda. Lambda is the wavelength equals, this is equivalent to where we have x again, which is 4 pi x over 5. I can now work again. All the ones that are the same, x and x, pi and pi. What's remaining here is 2 over lambda. What is remaining here? 4 over 5. I will then cross multiply. 4 times this is what? This time this. The lambda is what? 4 over 10, which is 2 meters, because they said all answers on all distances in what? In what? In meter. And anytime I range time, it is in what? Seconds. So this is the answer for the second question. For the second question. The third one, what are we looking for? Don't bother about speed copying. At the end, I will stop. You copy it. Understand it first. What am I looking for? The third? Speed of the waves is represented here. Can you look at it here? Frequency times what? Lambda. So I'll come here and say I. Speed equals f lambda. So speed will now be, f is what? Lambda is what? And what is it? 50 meters per second. 50 meters per second. That's the speed. Then what's the next? Again. So I have IV. Amplitude. What is the alphabet representing amplitude? And that is this over here. So I will write A. And A is equivalent to what in my question? 3 meters. So that's the last answer. Then write. Write down and then wait for your own turn. Questions will now begin to spring from everywhere. Because I believe if you're able to understand the game there, it means you can solve anyone, except if there's a very strong change. I can now come in. Wavelength is a distance. X is a distance. X is the horizontal distance. It will be, No, it is the question that will tell you whether it's centimeter, millimeter, or meter. Huh? X means X. That X means all horizontal. By X means all horizontal. Not only X, all horizontal. You can say all distances in meter. Or they can use X to tell you this is a horizontal distance in meter. And hence X is in meter. Wavelength must be in meter. Amplitude must be in meter. Side there, when we network of movement. When we network. So question guy be now. Small. Just understand the whole thing, the whole application here. Let us now come to the point. Are we all through? If I repeat this same question, in absence of that your notes, can you be able to solve it? I believe so. So let me now raise a question for you. Okay. Question 2. Okay, wait, it's still there. Every sample will be repeated. Another sample will also. But for this now, I'm going to give you equivalent. And what I'm timing only, I just keep to time. Because I know everybody will get it except the ones that were sleeping during the lesson. Can I read out? Okay. Now write. Oh, a block. The progressive wave equation. The progressive wave equation. Another question now, number 2. The progressive wave equation is given by y equals 0.25 sine into 0.25 sine into 200 pi x, pi t minus pi x over 4, comma, where distances in cm and the t in seconds. Where distances in cm and t in seconds. Full stop. Calculate number I, frequency. I, period of oscillation. I is frequency. I is period of oscillation. I, wavelength. 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 IV, speed. and V, amplitude. And V, amplitude. I is wavelength. I alone is what? I is what? Period. And I is frequency. That's 5 of them. Now get me the results. I'm counting on time. The first set, now give me the answers. Coming down. Why should they come down? How can they come down when it's a battle? Oh? It is a battle. Okay. What's the answer for frequency? 100 what? 100 hertz. Okay. Okay. After the frequency, period is what? 0.01. 0. What? 0.01. That's the next. Then what's the next? Wavelength is what? 8. 8 hertz. 8 hertz. It's 8. Hey, answer and cap. Wavelength is what? 8 what now? You must quote with the units. Okay. What is the speed of the waves? I want to hear that unit again. 800 centimeters per second. And what about the amplitude? Again. 0.25 what now? You know 0.25 is not an answer. It can be 0.25 anything. It's not an answer. It can equate 0.25. It's not an answer. You must give the correct result. The correct units. We gradually move up to, let's solve this and then move to the next level. The question is y equals 0.25. Sine what? Sine 200 pi what? pi t minus what? Pi x over 4. Okay. That's the question. Then the equation that will solve this problem is still amplitude sine into 2 pi ft minus what? 2 pi x over lambda. The same thing I gave you before, but now I'm going to change this after the question. Let me still have your attention. Oh, what is solve wolf in here? 10 times. Huh? Cheregodu, until you solve all of them. How can I be? Gradually. So here, number I is 2 pi ft equals 200 pi t. So this we go. So that f will be 200 over 2. And that's what? 100 hertz. You must put with the unit. After that, I have another II. II said what? Period, which is 1 over f. And this will give 1 over 100. And that's 0.01 seconds. So this is the answer to that one. That's period. Then I. Wavelength is 2 pi x over lambda equals what? Pi x over 4. Pi, and this we go. This is 1. So this will be 2 over lambda equals 1 over 4. If I cross multiply, lambda will be 8 cm. Because they gave us the unit already. You must go with the unit. That is sure. So this is the next result. Then IV said what? Speed. Speed. And speed V equals F lambda. Am I right? So that this will be F is what? Lambda is what? 8. And that will be cm per second. If you want to change it to meter per second, you divide by what? You divide by, If I want to, okay, convert this answer to meter per second. What will be the answer? Again. Internet 1,000 here. This will be 8 meter per second. I have to change cm to meter by dividing by 100 only. Then what's the next question there? Amplitude. What's the V? What is the amplitude? 0.25 what? cm. Thank you. Let me change the question. I'll give you the same question, but informations will vary. Now, right. Are we ready now? Are we ready now? Okay. Now, right. The progressive wave equation. The progressive wave equation. The progressive wave equation is given by y equals 0.04 sine into 2000 pi t minus pi x over 12. Pi x over 12. Pi x over 12. comma, where distances are in meters. 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 Distances are in meters. In meters. And T in seconds. And T in seconds. And T in seconds. Full stop. Calculate number I. Maximum speed. Maximum speed. Maximum speed. Number I. Maximum speed. I. Value of x in the equation. Value of x in the equation. About the serious. Value of x in the equation. If the phase difference, I repeat, value of x in the equation. If the phase difference, value of x in the equation, let me complete it, equation. If the phase difference is 60, if the phase difference is 60 degrees, phase difference is 60 degrees. Full stop. That's the question. When I represented the question on the board, somebody says it's the same thing now. But we're changing now. Let's go game better now. And many people will write solution, keep their pen, and wait for solution. The whole thing is gradually coming up, stage by stage. Maximum speed is 24,000. It's 24,000. No unit to equal units. I don't know what is 24,000. 251.43 watts meter per second. Yes. Some are doing good work. Yes. First difference is value of x. They gave you phase difference and asked you to calculate value of x. 25,000 meters. Yes. 2,400 for which one? For maximum velocity. Maximum speed, which is the same now. Yes. I'm an under solution. They were pen buribu. Today you are not doing anything. This one you jumped over to this side. Because I know many of you where you normally stay. Yes, yes. Network on the side. Let's go network. Okay. Yes, yes, yes. Do something, do something. Need a solution. Yes, yes. Anybody here? Value of x is but no unit. Oh, I didn't see any unit there. Value of x. Where's the unit? You did something reasonable, man. And when I better a unit. 24,000. 24. Any other person? Yes, yes. 12,000 meters. Okay. Okay. Now, please, I'm happy that some of us are really good readers. So. But our problem is just the development. When I started initially, it was as if we are not going anywhere. But gradually, you see ones that are doing well, very, very, very well. Now, look at the board. Please, keep the pen and look at the board. Let's summarize here. Please, look at the board. Can you hear me? Now, let's quote the question. The question is y equals what? 0.04 sine what? Is it 200 or 2,000? Pi what? Pi t minus what? Pi x over 4. Okay, over 12. Please. Can you see this on the screen there? Okay. Thank you. Now, let's look at the board. I want to match this. First, this is what I'm going to do. Please stop talking and listen. I will check the first two questions. But fortunately, there are only two questions. What's the first question? Maximum what? Maximum speed. That means I don't need frequency. I don't need wavelength. I can still use that frequency, but a long process. I want to introduce the two ways. Then, what's the second question? Value of x in the what? Equation. Thank you. Now, look up there. Now, for me to talk about, anytime I talk about maximum V, please turn to the board. When we treated simple harmonic motion, V maximum is given as what? V maximum is given as what now? Omega what? Omega R. Thank you. But I told you that under this now, R will be changed to what? I told you that this R is what? Is what? Hey. What is the meaning of this R? Hey, well. Thank you very much. When we treated simple harmonic motion, I told you that this arrow here is what? Amplitude. Thank you. And I told you that this arrow is equivalent to what? Equivalent to what? Maximum. Yeah, A. Oh. V maximum is equivalent to WA or WR. That position of R can only be replaced by what? By A and no other. That every other alphabet is a distance. Only R and A are called amplitudes. Are called what? Here I used that. I could go here before. Or they are in a note. Now simple harmonic motion. Is there already in the note? So look at the board now. So I am looking for V maximum, which is WA, which is what? Then this is what I'm going to do. If I want to shorten this now, I'll simply write Y Some people are still making noise. Equals A sine. I will come to the bracket and write WT minus alpha. I will shorten it. And when I shorten it, it will just give me direct answer. I can still use long program in getting the same result. But this is the shortest means. Then look at the board. I'll come to the board and say, WT is the same as 2000 pi t. T will go. So that the value of W will be what? 2000 pi. I will now write V maximum equals WA, which will be, W is 2000 pi times, this is what? A is what? 0.04. Now, 2000 multiplied by 0.04 will be what? So this is 80 pi meter per second. This is the answer. That is the answer. That is the answer. Only 2 persons presented their own answers out of the 3. That one of them got nearly this, but the other one got the second answer correct. Let me solve for the second. Look at the board again. Let's finish up. And the moment I finish up now, I will stop. Please, sorry for, because the chemistry took time. So I'm going to stop now. Okay. Now, shh. Look at the board again. Look up again. I can still solve this one now. Can you look up? Stop writing. Look at the board. I can still solve for this one in any exam by using the normal equation we know that W is equivalent to 2 pi F. I can still solve it. Hence I get the W, I go with it. Now, in getting this F now, it is the same thing we know. What make up F in this question? Questioner, can you make it F? 2000 pi t equals what? 2 pi ft of where? T will cancel T. Pi will cancel pi. F will now be what? 2000 over what? To give me what? 1000 hertz. If I have this, as I know before, I can come back and say W equals 2 times pi times 1000. This time this will give me again what? 2000 pi. Then V maximum will be WA. This is 2000 pi times what? 0.04, which is what? 80 pi meter per second. So the same thing. So I can still use this means to solve the same question. But let me ask this question. Is this one and this one, which one do you feel is better? The first one. Anyone you feel is better, please learn it and still learn the other. Then finally in that question, they said calculate what? Value of calculate the value of x. Please let's look at the last there. Value of x. If what now? If the first difference is now look at the board. I have the same question here. Please stop writing. Get the message, then you write. Get the message. From my equation now, you have here as what? Pi x over what? Equal to what here? Equal to the phase difference of where? Please stop writing and look up. I have here pi x over 12 equals the phase difference. Then, let me ask the question. What is the value of the phase difference? Again. So, if pi x over 12 is equivalent to 60 degrees over 1, and we said anytime the phase difference is measured in degree, what will be pi? 180 degrees multiplied by x over 12 equals 60 over 1. We then cross multiply. 180x equals 12 times 60. 720. Now x will be 720 over 180. And that is what? And that is 4 meters. So this is the last answer. Sorry, I supposed not to be here today, but because of yesterday's omission. So we'll continue the next. Our next class, please. I want you to help us read up water waves. Just read all characters of waves only. It will help you in the next development. So I'm going to stop here, please.